So here is the question on a funnel based scenario. So if we try to analyze this, so the question says a particle is rotating in the inner surface of a smooth funnel tracing a horizontal circle. You are asked to find the frequency of rotation of the particle. So now what is meant by frequency? The frequency means the number of times that this particle would be completing rotations in 1 second. So if suppose say time period is going to be some value, let's say time period of the circle, suppose if it is half a second, it means that every half a second this particle will complete one circle, and in 1 second it will complete two circles. So the number of circles completed in 1 second, that is going to be the frequency, or in other words we can say that frequency will be equal to 1 by time period. And so this is going to be a case of just like how we have a conical pendulum where a pendulum goes in a horizontal circle under the effect of mg and tension force. Here is a similar scenario where a particle is moving in the inner surface of a smooth funnel under the effect of mg and normal contact force. So we are given that the height of the circle from the base of the funnel, that height is h, and theta is the angle made by the axis of the funnel. So this line is the axis of the funnel with slant height, that angle is theta. So here we can try to draw parallels between conical pendulum and this particular funnel. For this particular funnel, it is going to be a uniform circular motion. There will be no force in the tangent direction. So tangent is going to be at this point going away from you. That is where the tangent is. So radial line is this particular line, and tangent line passes through the location of the particle and it is going away from you. So note that the tangent line should be tangential to this particular horizontal circle, and there will be no component of n and mg along the tangential line. So there is no tangential force. So it is a uniform circular motion. So we'll assume that speed of the object is v. Now note that this v and all we are introducing. If you look at the original question, only h and theta they are mentioned. Of course, you can use g also as an additional parameter, but apart from h, g and theta, you should not be using mass of the particle, normal contact force n, which is shown in the diagram. So all those things should not be made use of. So this mass m we will introduce to make the FBD, and normal contact force, there are two forces. So for analyzing circular motion, we need to make FBD. Then from alternate interior angles, the angle here become theta, and this is horizontal line, vertical line, that is totally 90 degrees. So angle made by the radial line with the slant height of the funnel, the angle over there, that will become 90 minus theta. So then we can say n vector will make an angle of theta with the radial line because n is perpendicular to the slant height. Right? And the angle previously we saw over there, I'll mark that angle. See, this angle will be 90 minus theta. So n will be making an angle theta with the horizontal. Now if we are going to write the equations, so we can say that n sine theta, vertical component of n, this should balance mg because net force perpendicular to the plane of motion, that should be 0, and n cos theta will be the only force along the radial line, and this should be equal to mv square divided by radius of the circular track, which we can write it as r, and I'm going to take r to be radius of the track. Now we'll divide the two equations. Why we are dividing? So that n will get cancelled out, m will get cancelled out, and we can see that tan theta, this will be equal to g divided by v square by r, so that r will come to the numerator. I can write as rg by v square. And look at this right angle triangle in the laser diagram which I'm showing. Tan theta will be equal to, in that right angle triangle, opposite side which is radius by adjacent side which is height. So tan theta I can write it as r by h, and note that interestingly r and r will get cancelled out, and we'll get a very interesting result here. So v square will be equal to gh, or speed will be equal to root of gh, which means that this particle will be going in a horizontal circle with this much speed, which is actually independent of the angle theta. So at a given height, whatever might be the angle of the funnel, the speed for the particle should be root of gh for it to move in a horizontal circular path. Now, going ahead to find out time period and hence frequency. So for time period, we know time period should be equal to 2 pi by omega, and v will be equal to r omega. V already we have root of gh, and r will be nothing but h tan theta. See, from this relation here, r by h is tan theta. So r will become, take h and multiply over there. Since r by h is tan theta, r will become h tan theta times omega, or omega is going to be 2 pi by time period. So I'll write expressions like this. Root of gh will be equal to h tan theta into omega. I can write it as 2 pi by time period, and 1 by time period is the frequency. Right? So carefully observe how we wrote this. Now from here, find out the expression for frequency. So required frequency is going to be h tan theta into 2 pi. So I'll write like this: 2 pi h tan theta divided by root of gh, or this can be represented as 2 pi tan theta into root of h by g. That is going to be the frequency of rotation of the particle. And note that now we have expressed everything in terms of the given parameters h, g and theta. Okay, so that's about this particular question of a particle rotating inside a funnel.